How green is the internet? When finding out how green something is, we need to take into account the environmental impact of three things. First, the prerequisites for the situation to happen. Second, the action itself. And third, that of alternatives if they exist. Let's apply this method to the internet. We'll take sending an email as our model situation. 1. The prerequisites. For people to send, let's say, an email, scroll down social media, or watch videos online, they first need an internet-connected device, such as a computer, a phone, a tablet, a car, or a smart fridge, a smart toaster? Next, they need to be connected to the internet through modems, routers, and their high-speed servers, and finally connected to data centers, servers that contain and distribute all of this data. Producing all this hardware has obviously a high CO2 cost. Manufacturing the average smartphone is estimated to create around 60 kilograms of CO2 equivalent emissions. However, studies show people receive and send around 150 emails per day on average. Most people keep their phone for about 3 years, so with a little napkin maths, we get 150 times 365 times 3 is equal to 164,250 emails. Now let's divide 16,000 by 164,250 and we get less than 0.1 grams of CO2 per email. Second, how much energy is actually used to send one email? As an email weighs on average 75 kilobytes, this means a negligible amount per email actually. And finally, we need to analyze in the same way the alternatives to email, such as paper letters. Producing the infrastructure to ferry all paper mail around the world, such as postman vans, postal service trains, and airplanes, and running them year-round has a much higher carbon footprint than what we previously saw. The carbon footprint of paper itself is often surprisingly good. In France, almost all paper comes from eco-responsibly managed forests. This means the carbon footprint of paper can be null or negatives, as the trees build themselves mainly out of the carbon they trap from the air. This carbon is not released when trees are cut down or processed into paper, as it is part of the main element of paper, cellulose, right there in its chemical formula. I lied. There is a fourth thing, how the situation evolves over time. Because with an industry as fast-paced as IT, and when looking at the question in its globality, we need to understand if and how the situation changes over time. We all know that the number of internet users increases over time, and that the internet's stake in our lives increases every day. With more people, more time per person spent online, better quality photos and videos uploaded and watched on social media and streaming platforms, the internet's energy consumption and therefore environmental impact must not only be huge, but also on the rise and through the roof, right? Well, actually no, the situation isn't that bad, but why? There are three main reasons. When considering the energy used by data centers or server farms, which differ mainly by purpose, one is mainly used to store vast amounts of data in the exabyte range, and the other is for computing power or data exchange purposes, there are two categories of energy usage. The first is the most obvious, but also quite abstract, the energy used for the computing itself, strictly speaking, the servers, storage, and networking equipment. And the second is all the rest, which is actually a lot. The whole cooling system, HVAC, AC, cooling towers, pumps, lighting, office electricity, UPSs, and every loss by every electric transformer from the high voltage lines to the servers and the racks. The ratio between those two values is called PUE, or Power Usage Effectiveness, and it measures how much of the energy used by the whole data center is actually used for computing. Companies operating hundreds of data centers, such as Oz, Amazon Web Services, Microsoft, IBM, Facebook, or Google, have started in 2011 a market shift from traditional data centers, built from off-the-shelf parts, to hyperscale data centers, designed from the ground up to be much more efficient. They use purpose-built hardware such as custom servers in each rack, which were ripped of everything that wasn't absolutely necessary. On average, each hyperscale server can replace almost 4 traditional ones. In addition, whole server clusters are computer run to move tasks in such a way that every server is either at full capacity or completely turned off, which has a 10 to 15% benefit in power consumption. As says Bill Carter, CTO of the OCP Foundation, we stripped out video connectors because there's no video monitor, there's no blinking lights because there's no one walking the racks, there's no screws. An engineer at Google has even developed a purpose-built AI to manage every setting of every cooling system in each facility, and after a rocky start, at first, they now boast a 30% reduction in energy use. This gives them, on average, the best PUE on the market of 1.11 only. So the first two reasons were automating control over the facilities and economies of scale, and the third one is simply that computers are getting better. Processor efficiency has always been up, and Moore's law has, until very recently, been true to its word. Many big tech companies have also pledged to be 100% renewable powered, and while they aren't there yet, they are taking the right steps towards this goal. I lied again, there's actually a fifth thing. Whether there are alternatives or not, we need to ask ourselves.
Is the Galaxy S10 worth it?
Because let's face it, there are very little alternatives to the internet, and often none at all. Using mail instead of email makes a transfer time of a few seconds extend to 24 hours. And you can't have video on demand through the mail, nor on live video conferencing, something we have grown to be thankful for in these times of home confinement. So even though the internet has a non-negligible impact on the environment, it is a great tool we need to both use correctly and improve to be more useful, more accessible, and more eco-friendly.